Hope you have completed the lab also. So we are done with the fourth chapter. So there is so in this section we have seen how to manage information secrets. So managing sensitive information secrets. Then we have seen about controlling application permission with security context constraint. And there is a practice lab. So after this one. So this lab you can do after the class hours. Okay. So this lab there will be a question. So you try to work out that question on your own. So these questions will come from this covering these two sections together. You try to work out that questions. It will be in the exam. You'll see like some similar questions like this. You will be working on this task. So try to work on your own and grade your work. So here there is an option to grade. So there is evaluation. So where if you run this grading script, it will grade your work. Grade your work in the sense that whether you've done that task correctly or not. It's going to grade that work. So if it is done correctly, you will get pass. If it is not, you will see that particular task will fail. So make sure that is getting pass. Then you can finish this one. In case if you have any doubts, if you want to know about the solution, how to work out that, there is a solution also there. So there is a stepwise solution provided at the back. You can go through this solution in case you cannot getting any answers correctly. So this lab you can work out after the class hours. So because it requires some time, you have to sit patiently and understand different scenarios, try to work out on your own. So it requires time to do it. So you can do this lab after the class hours. So this will just give an idea about how the questions will be in the exam. So the exam also will have something like this. They will give you a task. You will work out the task. Then your work will be graded using the grading script. And based on that, you will get the marks. And based on the clearing score, you will be able to clear that exam once you pass a specified score. Okay, now we'll move on to the fifth chapter. So fifth chapter is very important. So here we are going to configure Openshift for networking. So configuring Openshift networking for application. So this is about networking. It's a very important chapter. So here we are going to see three different sections. So troubleshooting Openshift software defined networking, and we are going to see about exposing application for external access. So we'll see how to control the inter-project communication using the network policies. So these things we are going to see. The first section will be a little bit elaborate, so you have to, because that will take some time, the first section on all, because you have to see a lot of concepts over here. Here we are going to see troubleshooting part. So how to do a troubleshooting at the networking level. So first we'll understand the flow, understand the networking flow. So how the flow is from internal to the external to the cluster. So how the flow is happening. Then we have to see how to access the application. So how the applications are internally accessed and how it is accessed externally, how it is load balanced. So all these things we have to understand on this troubleshooting part. So we'll understand the flow. We are not going to configure any new things. Like we will use the existing things. So already the things which is will be created by default. So we'll be using that existing things, and we will be able to use that things and to understand different concepts. Okay, so the section is troubleshooting the Openshift software defined networking. Okay, so this is the second name. So first is about introducing the Openshift software defined networking. Okay, so we need to know what is SDN. So SDN itself a wide concept. So it itself a separate domain, the SDN, software defined networking. So we have the SDN at the back. So at the back of the Openshift and the Kubernetes, the SDN is doing the function. So whenever we create any application, so we have seen that you might have noticed that there was an IP address got assigned to that pod. Whenever we create a pod, there was an IP address assigned to that pod, and the pod was through that IP address we were able to manage that application, communicate through that to that application external. So we are going to see that. So the primary component which is responsible for doing all this is SDN. Okay. So there are a lot of SDN components being inside, and the first reason why we are going for the SDN. So the reason for going for the SDN, then we'll see the SDN architecture. So the first reason why we are moving for the SDN is we need to adapt to the dynamic nature. So there we need a network requirement where the networking has to adapt to the dynamic nature of the environment. So here the Kubernetes environment, there is a dynamism inside this. For example, there will be a scaling mechanism. So the scaling you can do manually scaling can do the automatically. So automatic scaling factors are also there. So when there is like when you are doing scaling manually, so when you scale the application, for example, I scale the application from 50 to 100. So each application will get or each pod will get a unique IP address. So when you scale it, there will be 50 IP address need to be assigned to that pod. When you descale it, so the 50 IP address has to be released to the pod, and the IP address has to always be assigned to an interface. So the pod has to have an interface, so that to the interface only we can assign an IP address, and this interface has to connect to a switch or connect to a router to have a routing mechanism, or you have a like you can have a communication mechanism between different LAN addresses. So there is a requirement for that. So when I want to realize this thing through the traditional network, it is very tedious. Like I want to create because when I scale it, I want to create a physical interfaces. I should have the available physical interfaces to assign an IP address to it. So there should be someone to take care of IP address assigning and IP address releasing that. So then somebody has to take care of the protocol mechanism, the protocols for communication. So then somebody has to take care of managing the physical switches and routers. So all these things are very tedious when you want to realize the same thing in the traditional way. So I want a programmatic approach. So I want to realize something which I can adjust it in such a way that it's not going to like it's going to be flexible for me to do that. So there comes the SDN into the picture. The SDN helps me to realize the networking components in a software way. So in the server itself, we can realize the SDN component. We can realize the routers, switches, bridges, and the interfaces. All these things can be realized as a software component. So that we can control something like in a programmatic way. We can control that things. Whenever we want to increase it, we can increase it. Whenever we want to decrease it, we can decrease that to our requirement. Nothing is getting affected. And so the thing is that we have to have sufficient resource on the server. Apart from that, there is no requirement for the physical switches, physical routers, and all these things. But also, I can control this the way I want. I can program it the way I want, so that this will be controlled in an automated way. So that without even the knowledge of the SDN, so which is at the background, so the operation will be going on behind the scene. So this is the reason why we are going for the SDN. So here they are given some reasons for adopting the SDN. So here you can see managing networking traffic and network resources in a programmatic way, so that organization team can decide how to expose their application. So this is one reason why we go for this SDN. SDN satisfies this requirement, and it takes care of the communication between the containers in the same project, in the different projects, in the same cluster, and it takes up communication between the pods which belong to the same project or in the separate project. So networking communication from pod to service. Later on we'll see about what is this service, and then networking communication from external network, so from container to the external network. So external communication from the internal to the external to the cluster. So all these things will be taken care by this SDN. And what is this SDN architecture? So SDN itself a very big concept. So but we will see what is SDN in a short. Just we'll understand the basic building block of SDN. So after that, you can based on your interest, you can explore more about SDN. So since we don't have time to explore more on the SDN, we are going to just understand the basic building block of the SDN. SDN has 3 different layers, or we can say 3 different planes. So the first, the bottom one is data plane. The data plane is a place where you are realizing the software components. So you are realizing the physical components of the networking devices in a software way. So like the routers, switches, like that. And here you have the control plane. The control plane takes care of the traffic movement. So the control plane has got a big responsibility, is that the control plane should not compromise the traditional networking protocol. So there should be a communication, there should be a means of control of communication between these devices without compromising the traditional network protocols. Traditional protocols like TCP, UDP, the other application layer protocols like HTTP, SMTP, like that. So we have a lot of protocols. These are the traditional networking protocol. This protocol should not be compromised. So we should not say that you have to use a specific protocol when you want to use SDN. So the idea behind is, when the user uses the SDN, he should not realize that there is some SDN behind it. He should realize that there is some physical network is happening behind it. So to that extent, it should provide a flexibility. So Only the core user should know there is SDN behind it, but the normal user should know that there is something, just normal networking is happening. But we are realizing that without compromising any traditional network protocol, without affecting that protocol. That protocol should work because that layer should not be disturbed. So that will be taken care by this control plane. So it will take care of the traffic engineering, like quality of service things. Then it will take care of routing, the data movements, and mobility, mobilization of data movements. So that will be taken care by this control plane. And at the last, we have the application plane. The purpose of application plane is to get the information from the SDN or to interact with SDN and to fetch the information. So for example, I may be a SDN service provider to a client. So how much the client is utilizing my SDN? So how much the client is creating these things? I want to monitor that things. I want to monitor the security things out there. So there you can use the application plane. In the application plane, you can have the third-party applications deployed over there to monitor the SDN activity. So actually, the application plane is not a strict requirement. So it is only requirement when you go for the large-scale SDN deployment. So the application plane will be useful for us. So if you have control plane and data plane, sufficient to get going with the or get started with the SDN. So this is a SDN basic architecture, and there are a lot of SDN products available. So like we have here OVS, so we can call Open vSwitch. So there is a company called Open Daylight. So they provide this. Inside the OpenShift, we have this OVS. So this will be creating the OVS bridge and switches. So that will be created inside the OpenShift. So whenever you create the pod, that will be connected to this bridges. Through that, we are able to communicate to that pod. So we have the OVS inside that. If you want to go for other products, you can have Cure. This is also SDN product. You have Neutron, which is basically used on the OpenStack platform. If you have used OpenStack, you might have known what is Neutron. So there are lot of products apart from this. So you can OpenShift is using primarily the OVS. So if you don't want to go for OVS, you can configure different SDN things also. So you have the options to configure that. So whatever the products which you are interested in, you can do it. But if you don't want to disturb that hierarchy, you want to go, because normally the people will not touch that SDN components. So unless you have a use case to do that, so normally it will just run with that. It will be enough to run with that. But if you have special security reason to modify something, if you don't want to go with the OVS, you can go for other plugins and you can use it. Like you can use a Calico funnel. Like you have a lot of SDN components are there. So you can use one of them to configure as SDN thing. So which will provide the backbone SDN to the pod networking. So we'll start with the networking model. So we will understand a networking model. So since our focus is on troubleshooting, so for doing any troubleshooting, you should have a model of how the process happens. Then only you can troubleshoot that process, how the process is flowing or how the data is moving within the process. So you should have a model of that. Then only you can see which layer the problem is happening. So you should have a model to understand that. So we are going to have a basic model for the networking. So we'll understand that model. So we always use this model when we are starting to do any network level of networking level troubleshooting. So in the OpenShift, we have 3 different layers. So starting, so we can call the first layer is the application layer. So the application layer starts with the pod where you deploy the application. So this is the application layer. The second layer, which is there in the networking, is the service layer. So this is the service layer. And the last layer will be the route layer. The route layer. So after that, the application. So the main idea behind this model is that this just gives you an idea how the application which is running inside the OpenShift cluster will be reached to the client. So here, for example, we have the pod over here. So this is a pod underneath this application layer. So we have the pod. How this pod is reached to the client. So how the client is accessing this pod or application. So that's a basic idea. So how how this is happening. It is going through these layers. So the problem can occur at any one of the layers, or you may be in charge of configuring this layer. So that at the other side we have the client. This is a very important model, which is can remember too when you do a troubleshooting. So you will face the issues on any of these layers. So you may be facing that. So if you know this model, and if you know how the things are working on different layers, then you can easily start your troubleshooting. And these two layers over here, this two layers, this is service and application layer, is responsible for internal communication. So internal cluster communication. And the last layer, which is the route layer, which is responsible for the external communication. With the route layer, we are going to do something externally. So external to the cluster, how a client, because client is outside of the cluster. Client is not, will never be inside the cluster. The client will be always outside the cluster. Outside to the cluster, how the client is going to communicate. So the external communication element responsible for this is the route layer. And also you can, without the route layer also you can do the communication. The route layer is, as per the Kubernetes, the route layer is not strictly required. With the service itself, you can directly do a external communication. But from the Openshift perspective, from the enterprise grade or production perspective, so we required a route layer. So for the purpose of secure deployment, we require this route layer. But strictly speaking, the route layer is optional. So without the route layer, you can use a service directly to communicate external to the cluster. But we have to follow this model. So we have to have a route layer which takes care of the external communication. We have service layer and application layer, which is internal communication. Which that means using this, you can able to internally communicate to the application. Internal means inside the cluster. So inside the cluster environment, inside the worker nodes, from inside the master nodes. Through that, you can able to communicate with the application. But externally, you can never communicate using the service and the application. But you can do some modification into the service. There are different methods like load balancer method, node port method, like that. So using that, you can use the service to communicate externally. So without the route layer itself. But here we follow this model strictly. So there are a lot of ways you can do this, like you can modify, you can have different ways to expose this, but we strictly stick to this model. But if you know Kubernetes, or if you have done Kubernetes certification, you know that you can directly use the service layer for communication also, but that is also possible. So, but here we will stick to this model. So this is a basic model we have to understand. And now we'll start with the application layer. So we're going to see what are the things we'll have at the application layer. So far we have deployed the application using the something called OC new app command. Yesterday we have seen there are two ways to deploy the application. So far we have used the OC new app command to deploy the application. There are other ways to deploy the application also. So using the declarative architecture. Starting from here, we'll follow this declarative architecture. We'll have a declarative file. Through that file, I'm going to create the resource through the file. I will define my input in the file. Through the file, I'll create that resource. Yesterday I've seen. So for deploying application, we have two methods to that. We have the imperative architecture, where you use the OCNAP command to deploy the application. Then we have the declarative architecture, so where you'll say your input inside the file. Using that input, the API server will get your input. It will analyze the file. So once the inputs are proper, it will create that resource. So that is another way. So we are going to see this declarative architecture. So the application, so we are going to follow this model. The first layer will start in the application layer, the application pod which we are deploying. So we are going to see the events. What are the things that are happening when you first deploy the application? So when you execute that command, or you can say when you create the deployment. So what are the events that is happening when you create that application? So we are going to see that using that declarative architecture. So we'll do that. So and go to the one. I'm going to create a project. Let me create a new project. So see new app. This is a new project. So I'm going to say this is my demo 4. So see new project, my demo 4. So I'm creating a new project over here. So inside this, I'm going to create the application. And so I'm going to use from here Red Hat training. So here I'm going to use a special image to understand some concepts. So we're going to understand the scaling and all these concepts later on. So for that, I'm going to use that particular image. So you're going to use an image called scaling. I'll be using an image called scaling. So this image is particularly designed for understanding some scaling operation. So for example, if I scale the application so 10 times, the scaled application will be a similar application. So I need a way to know from which application I'm getting a response. So which application is replying to me. To understand that, this application, this image is designed in that way. So it will just give you the IP address of that particular pod. So whatever the pod you are creating, each pod will have an IP address. So that IP address of that pod will be shown as a reply, so that you will see that you are reaching the different pod. So you'll be convinced that you are reaching. Once you scale that application, you are reaching a different. For this reason, so we are going for this image. So under this Red Hat training, I'm going to use this image, and you have to check the tag. This is the latest refine, so it has the latest tag. So I'm going to deploy it. So for deploying it, so I want to have a declarative file. So the declarative file I have created, I have a skeleton file created on this downloads. I've created a file which is okay. I can create a directory and say this as demo directory. Creating a directory, copying some file from here. We go to this directory. So here I have the file. So this file, now rename this. So in the Kubernetes, you'll be writing this file. For the sake of simplicity, I'm just here going to use the file which is already available. So the primary thing which is required for the application deployment is the deployment configuration file. So we have the deployment. So once you have the deployment, we have the replica set defined. Then we have the pod. Inside the pod, we'll have the container. So previously we are using the OC command. OC command, what it did was it has created the deployment image stream and services. Now I'm going to create the declarative architecture. I'm going to create these individual entities. So I'm not going to use the OC command. OC command, if you create it, it will create all these things. So you need not go and do that. So here I'm going to create the deployment. For that I have a deployment file defined. Inside the deployment file, we'll be defining the replica set, the pod, and all these things. So I already have this file, and you can always compare this one with the yesterday we have seen the declarative architecture. You can compare this in the chapter 1. So this one, the I think you hope you remember the box model of the deployment. You have the deployment. Inside the deployment you have replica set. So under the template you have the pod and all these things. The same thing I have written that as a file. So here in this file. So here you can see the file. Here you can see the basically 4 things are essential to write a declarative file: the API version, kind, metadata, and spec. So this API version I'm mentioning here. So this is the deployment. The kind is deployment. So you can name this application. Here I'm going to say this application as just simply as my app. I'm naming this application. So from here in the specs section, whatever you're starting with the replicas. So you're going to say the replicas. So let's say 3. So when you create that application itself, that time itself, it will create 3 applications. So that is the replicas. Then you can specify a label for this replica. I can just specify the label to later on we'll see the uses of this label. So this will be the label for that deployment. So through that label I can call that deployment. I can do some modification over the deployment. And then from here the template section onwards the pod definition starts. Up to this the replicas. Actually replicas includes all these things. So replicas is a superset. It's not like only that there. You look into the box model of that. So you can see the replica set includes everything. Okay, this is the replicas. Like the deployment includes everything. So like replicas and all this. And so replicas is a subset of deployment, and pod is a subset of replica set, and container is a subset of pod. So when I say replica set, it includes all the things together. So these things together it includes the replica set. And then here it starts from the template, it starts the pod definition. So here I'm just, the metadata is just information to give a label. So to label that pod. So whenever we create the pod will have some label to identify it. For some reasons we need to have some labels. So you mention that label over here. So here I'm mentioning that deployment code. Any label you can use. I'm mentioning this label here. Then here under the spec section starts the container definition. So you can compare to this box model now. So under the spec section you can see the containers definition starts. So the container definition, so here I'm saying the image. This is my image. So the image which I'm getting from qa.io, red training, the scaling, that is the image which I'm getting from there. You can mention that image here. Then you can name this container. So I can name this container my any name, because to be universal, I'm just saying that it's my app. You can give any name over here, so any identification name. So that will be the name of that container. And the container needs to be accessed through the port. So this is very important. So I need to specify a port for the container. And so you can define multiple ports for the container. So here I'm defining 2 ports. One port is a insecure. So like normal web server. So insecure server, I can access it. Another is a secure, like 8443 will be mostly used for secure things. So you can create in a general way. You can expose that through 2 different ports. You can have multiple ports for the containers. So I can use this one for the insecure access. Another one I can use it for the secure access. So as a general way. So I'm just saying that port, and the protocol which typically we use is TCP protocol. I'm mentioning the protocol details here. This is the deployment file definition. So using this file, I'm going to create this application in a declarative way. So in this project which I'm currently in my demo port, I don't have any resource so far. I just do OC get all, so we will not find anything. Now I don't have any pods. I don't have any pods. Also I can look into the watch window, so you can see that I don't have anything in my demo port. Now I'm going to just create the deployment. So I'm just going to create the deployment. So I will point out to this file OC create. So this is a command OC create, point out to the file, point out to the resource, whatever you want to create. So this is a general syntax. So when you want to create anything through the declarative architecture, the general syntax will be OC create. Here in place of create, you can use other options also. OC create. Sometimes you want to replace it. Then in case you can use OC replace. Sometimes you want to use OC apply. So you can use different things over here for the declarative. But usually I use here create. So OC create. OC create, I have to point out to the file. So -f, what are the file resource which you have defined. So this can be anything. So it can be a deployment, or it can be a service, it can be a route, so anything. So just point out to that. So once you point out, what happened, that file will be taken as input. That file will be read by the API server. The file syntax and everything is fine. You will see that resource getting created. So now for me, what it will be creating is the deployment. So deployment will be created, then the replica set out of that deployment, then the pod, then the container. So this will be created. So I just point out to that file, which is over here, myapp.yml. I'm pointing to this file. So once I point out, you can see that deployment is created. So once the deployment is created, the pod will be automatically created. You can see now it started creating the container. So pod will be created. Inside the pod, the container will be started creating. You can see now it is running. And now what are the things you will see? So when you use OC get all, you are going to see only these things. You are going to see deployment, replica set, and pod. Inside the pod, you have the container. Once you describe the pod, you will see the container information. So once I do OC get all now, you will see that. So I have the pod, I have the deployment, I have the replica set. So there is no service. So since I'm not using the OC neap command, there is no service. Only you get the service when you use the OC neap command. You will see the service, image stream, and deployment. All these things will be created. Through the deployment, I will have this. Now I have created only the deployment. So through the declarative, I declare what my input is in the file. It's a very simple file. I've declared my input, like what is the image which I'm getting it from, and what is the port for that container. All these things I'm defining in the file. I'm creating that resource. Now this is created. This is the other way. So so far we use the simple method to create it, which is using the OC new app command. Now we'll go to the other way, which is using the declarative architecture. So declarative architecture, we use the OC create command. We'll define our resource in the file. Through the file, we'll create that resource. This is the other way to create it. And mostly you'll find when you're studying about the Kubernetes, mostly you find that declarative architecture. So through that file, you'll be creating these resources. Okay, so from the network perspective, we have to see what are things we have achieved, what are things has taken place in the networking context. So we have created the pod. Now the pod is running. OC get pods. When I do OC describe pod, the name of the pod is my app. So here, see now when you describe it, here you can find the events which has taken place. I'm just going to just grab that events. Grab for 7 lines to the events. You can see the events that has taken place with that pod. You can see here. The first thing that has happened is scheduling. So scheduling is happening. What is happening is the scheduler, the default scheduler, is successfully assigning this pod inside this project to the one of the node, which is the master one. So this is what the scheduling is do. The scheduler is again running on one of the projects. You can verify the scheduler where that scheduler is running. You can do OC get pods -o for this OC get pods. You can mention the project name, Openshift -cube scheduler. So here you can grep for scheduler. So there will be other additional pods. You can just grep for the scheduler. You can see that it should be scheduler. In the grep, I have to use small s. Now you can see here. You can see the scheduler. So this scheduler is what deploying this one. So this is running as a pod itself. If you describe that pod, you will see that the pod name will be default scheduler. So that is scheduling this application to the one of the worker node. So here in our case, the master node itself is acting as a worker node. So you'll see this as a master one. In real time, you'll not see this. In real time, you'll see the worker node. So that is the first thing happening. The second thing which is happening over here, I think just more line. The second thing happening is there is interface added to the pod. The pod is adding an interface to the the pod is getting an interface. The interface is added. So this is added by a component called multas. So multas is an SDN component. So we call this multas as CNI. CNI stands for container network interface. So that interface is added to the container. So the pod. So the container is still not up. So first the pod level things are happening. To the pod, interface is added. Ethernet interface is added to the pod, and this is added by something called multas. So this is what happening. It is adding that to the container. Then after adding the Ethernet interface, this is getting an IP address. So this multas is also running as a component inside the Openshift cluster. You can view that. You can use OC get pods Openshift multas. Inside this, you can see a multas pod is running over here. You can see this pod, and this is what adding interface. So see, this is a multas is a container network interface. You can read about multas in the book. Here you can see the multas CNI. CNI stands for container network interface. So instead of this multas, you can real time you can use funnel, calico. So that kind of things also you can use. But here we are using this multas, which act as a CNI that provides my interface. So Ethernet interface. Then you see an IP address is assigned. So you can see the pod has got an IP address. So this is very essential thing. So this is assigned to the pod. So who is assigning this IP address? So the IP address is being assigned by a network operator. So there is a network operator. So that network operator actually assigns the IP address. You can use to see that you can use OC get using this command OC network. So I'm just going to see the definition file of that. So here I want to see that in the JSON format. So if you look into this, here you can see in this definition. Here you can see the CADR block. You can see the range, the range of that IP address defined. So this is a reason why I'm getting this one in the 10 dot series. You can see this IP address assigned to the pod is in the 10 dot series. So it's because so it is defined in that network operator in this range. So this is defined during the installation time itself. So during the installation time, so they will define what is the network range the pod should be. So they will configure this network operator. In the network operator, they will define what is the range the IP address should be given to the pod. So we have to define the range. That range will be defined in this network operator. So this is what responsible for assigning this one. After that, once the pod is ready, so once the pod is scheduled to a container or once scheduled to a worker node, it has been added a Ethernet interface by the SDN component, which is multas. After that, it has been assigned by a IP address by the network operator. Then it starts then the kubelet. So then the kubelet in the node starts pulling the image from this repository. It successfully pulls. Then it is creating the container. Then it is starting the container. So this is what happens at the application layer. So once you deploy the deployment, so this is what starts in the application layer. So first thing, so any typical application which you are deploying inside the Openshift, so this is what happened. So the scheduler is first try to schedule it depending on the requirement. So how much, in case in the declarative file, I can define a lot of requirements. I can declare my CPU requirement, memory requirement, all these things. So that will be taken into the consideration, and it will assign to the suitable worker node. So once it is assigned, then it will be added an Ethernet interface. and once the Ethernet interface is added, an IP address will be assigned to that. There are different components responsible for that. Then the kubelet, it will interact with the cryo. So the cryo will pull that image and it will create that container, then start that container. So this is what happening at the application. This is the first basic starting point. So we have to understand at the application layer. So the same thing you can see at the whatever we discussed. So this is the basic networking model. So inside the worker node, you will find this OVS bridge will be there. This is inside the worker node. So we will not go into that detail and see that, but you will see this. There will be OVS bridge. So once the pod is created, Ethernet interface added. So this pod will be connected to this OVS bridge. Through this OVS bridge, we will be able to connect to that pod from the external network. So this is what happens in the worker node. So this everything will be created by the SDN component inside the worker node. So you have to understand this is what happening at the application layer. This is the basic thing happening at the application layer. And after that, we'll move on to the next layer, which is the service layer. So we'll stop up to this. Now we'll go for the lunch. So we just completed the application layer part. So the basic model. So in the application layer, so we have understood on the application layer we have the scheduler working out there. Scheduler, Multas, the network component. Then we have the kubelet. Kubelet, cryo. So all these things are working at the application layer. Then you have the OVS bridge. So all these things are happening at the application. Once you deploy the application, these are the things happening at the back. So the application layer, these are things. Then only the application actually starts inside the Openshift. So this is what happening in the application layer. Then we'll discuss about the service layer. Then also we have to see about that IP address. So using that we can directly communicate to the application. So we'll see that also. So after the lunch we'll continue that. We'll continue back by 2:30. We'll start in the next section.